Today we're going to take a look at analysis of the IHME coronavirus forecasting model. The IHME is the Institutes of Health Metrics and Evaluation from the University of Washington. This information is an update of the April 14th model. Certainly the coronavirus is having a major effect on the economy, and the agricultural economy has probably had a worse week than the general economy over the time, with markets backing up. During the last month, roughly 22 million U.S. workers filed for unemployment due to the shutdown of a significant share of the U.S. economy. It has been clear that the Institute for Health Metrics and Evaluation has been playing a large role in the formulation of the policy. Certainly governments are taking a look at this. Certainly universities are taking a look at that and trying to make decisions with regards to moving forward. I think it's really important to document and understand the performance of the prediction model and the revisions that are made to the predictive model. This is an update of the session we taped on April 14th. In this last week, there was one more release of the model. We talked about in the first session, and again, if you want to go back, take a look at the April 7th thing. Again, the original model essentially was just a statistical model. There was not much epidemiology within that. It was a parameterized spline where they assumed a functional form. They used a curve fit, fit and log space, a sigmoid shape that we end up having over on the right hand screen. A very complex nonlinear optimization problem. Used a fairly complex algorithm to numerically solve this. The thing that's unique about the LBFGSB algorithm is that it does require derivatives in order to solve the problem. Again, the data came from WHO websites and then also the Johns Hopkins coronavirus data. It is important to note that the article has been submitted for review. It's available on preprint, but again, as of April 21st, it has not went through the complete peer review process. The data that we use to update the information comes from two sites. One is the WorldMeter site. The other one is this COVIDtracking.com site. And so with that information, we will evaluate the accuracy of the model. This is the Kansas model. The numbers in red are essentially the actual deaths. The green represent the lower and upper bound, and then the purple represents the mean forecast from the original model. In terms of one of the things you can quickly see is, while there have been some days or some observations where the daily death projections actuals exceeded the projections, most of the time it's been well below the projections, and most of the time it's been outside the 95% confidence interval between the green lines. One of the things we'll display here and talk a little bit is kind of what's going on with the U.S. And this is one of the things that makes forecasting very difficult, is that some of the states did a revision with regards to the way they were collecting data, and that data ended up lumping all on one day. The important thing that ends up doing is, with these highly nonlinear models, it really makes complexity. And so some of the times you want to determine, actually you would want this data kind of spread out through the whole time period, but what it ended up doing is just hitting at one point in time. And so it certainly does make difficulty there with regards to estimating models. This might be a classic case of an outlier, but in some respects the numbers in red may have been undercounted before, and so in order to look at that, it appears at one point in time, but certainly it affects the modeling approach. And in some respects, most of this came from New York in one period of time. One of the things we've added since last week is 4 additional states. In terms of looking at this, you can see that California has typically performed the original forecast in terms of the number of deaths. Actual are quite a bit, are normally less than what the projections are. They're kind of in this purple to green range, which is within the 95% confidence interval. If we look at Florida, same type of thing in terms of early on. Projections were under what actually occurred. More recently, there's been kind of a fairly level trend with regards to the deaths. And again, you'll see that some of the current estimates now are outside the bounds of the original model. We have the number for Illinois in terms of, again, looking at this. There were times where the projections were under the actual deaths that occurred, and then there were those that were above. And then we look at Texas, same type of thing with regards to as Florida, where again it is a slight incline, but overall much less than the original projections, and they're below the lower bound. The slides you can get on the agmanager.info website, and so if you want to take a look at those. One of the things we started looking at last week was just basically looking at the forecasting performance of the March 26th model. Some of the things we were looking at is we're looking at the root mean squared error, the mean average, mean absolute error, mean absolute percentage error, and then the bias. In terms of looking at these, in terms of essentially positive numbers, means that the forecasts were greater than the actual. You'll see that this is different for the U.S. and in New York, and most of that is affected by the revision in data. If you compare these numbers with last week, you'll end up seeing that last week they were positive. In this case, they were negative. In terms of the models, in terms of the mean absolute percentage error, you can see that some of those are pretty high. New York is relatively low, Illinois is relatively low, and the United States as a whole are relatively low. But if you look at Kansas, Florida, and California, they're more than 100% off in terms of the mean absolute percentage error. Certainly in Kansas it might be due to the small numbers, but in Florida and California that's less likely the case. Then we have the cumulative projections. The big thing here is you'll see that Kansas is below the 95% confidence interval, that green line, and it continues to diverge from the original forecast. We have the U.S. projections here. Even with the change in data definition, it remains fairly close to the original projections. Here you can see in New York, the adjustment that they made essentially moved it from following the purple line almost to following the upper bound there with regards to that. California, in terms of, it looks like those projections, essentially the actuals have focused more and followed more the lower bound. Same in Florida. And then if you look at Illinois, in some respects, the actual situation has followed fairly closely to the original March 26 projections. And then you look at Texas. Again, Texas is following more along the lower bound as opposed to the mean projections. In terms of looking at this, essentially you can look at the forecasting performance here of these models. Same type of thing in terms of, again, there is positive bias in California, Florida, Illinois, Kansas, and Texas. What that indicates is that the model overpredicts the number of deaths in the U.S., and in New York, the model has actually underperformed. And you can get a little bit of an indication with regards to this. It's much easier to forecast the cumulative death projection than it is the day-to-day, and you'll see this by much smaller mean absolute percentage errors. In terms of looking at this, the U.S. as a whole is 4%, 7% for New York, 5% for Illinois. And then Texas and Florida both are at 18%, Kansas is at 34%, and California is at 51%. In terms of one of the things we'll look at is, and again, we'll let you study these. We have 7 of these graphs that basically look at how the forecasts have changed. What we're going to spend time here is we're going to spend time looking at the mean from the original model versus the mean that was released on the 17th, the most recent aspect. But again, in terms of if you compare the purple line and the red line, you can see that the original projections over forecast, or they've reduced the forecasted deaths down quite a bit from the original model. And you can see that there has been quite a bit of divergence with regards to the model. One of the things we looked at last time, and we've updated these numbers, is in terms of looking at a 1-day, 2-day, 3-day, 4-day, basically trying to get an indication of how well these models forecast out a sample. Pretty much the same type of last time is that after 4 days, the bias becomes to be more of an issue. In terms of if you look at the mean absolute percentage error, certainly it's there. One of the things to even look at is the bias divided by the mean absolute error. If every observation is below, then you'll have 100% there for the bias over the mean absolute error, meaning that every observation is below. One of the things you'll see is that not so much the case for the first 3 days, and then you get up in the 70 to 80 range there. And essentially for the first 4 days we have 9 models we're averaging over, days 5 through 8, 8 models, and days 9 and 10 we have 7 models that we're looking at. In terms of, again, back to the original, we're looking at the purple line and the red line here. For the U.S., in some respects, you'll see that the most recent model is not too far off. It is forecasting a decline a little bit quicker than what we saw originally. With the New York model, previously, all the models were pretty much the same, but with the recent release, they actually increased the daily projections and basically indicated that it would be a longer time before the model went to 0. In terms of California, you can see the original model in purple, and then you can see the red model. Again, you can see a very big divergence with regards to the model forecast. Again, there were 4 that were fairly close, and then there was an adjustment down in the models. Florida, again, you can see the difference there. Again, you'll see quite a bit of divergence between the original model and where we are now. Same type in Illinois. In some respects, if you look at the red and purple lines, they follow a little bit closer. And then Texas, again, you see a pretty big divergence with regards to the original model and the most recent model that has had more data to look at it. One of the things, and again, these slides are available on the agmanager.info, you can kind of look at when the peak date was going to be. In some respects, for example, the U.S. in terms of its ranged from April 12th to April 16th. If you look at these models, in terms of the last model, basically all 6 of the states plus the U.S. is past the peak. But you can end up seeing how these bounce around. In terms of Florida, from the April 12th model to the April 17th, it went from May 6th to April 12th. Early on, it was May 4th. Texas, same type of thing in terms of early on. It was in the May 7th was kind of the peak day in terms of the model now. Suggested that April 19th was. And so in some respects, basically, the more recent model suggests that we have reached the peak in each of these states plus the U.S. Again, we'll go through these fairly quickly, but again, focusing on the red and purple line, you'll see basically quite a bit downward revision in the cumulative amounts of death. You can also take a look at this in terms of the percentage models. Again, you look at the bias begins to increase after the third and fourth day. Again, the mean average percentage error continues to grow, as does the root mean squared error. One of the things, 5 days out, 9 days and 10 days out, in each case, all of the models basically over-predicted the cumulative number, and you'll see a lot of numbers here where essentially you get that over prediction. Looking at the other states, you have the U.S. again from the purple line to the red line is kind of the adjustment in terms of from the original model to where we are now. Again, New York is a little bit different case in terms of essentially we were pretty close in that 12,500 to 15,000 range. That now has jumped up to an estimate of about 22, and so that has changed over the last week. In terms of California, basically projection over 4,000 deaths to less than 2,000. In terms of Florida, a projection of nearly 7,000 deaths to now about 1,300. Illinois, in some respects, if you look at these purple and the red line there, they're very close. And so in that respects, the experience in Illinois is following fairly close the original projections. Texas, again, you'll end up seeing quite a bit of an adjustment. Early on, there was an adjustment upwards, and then more recently, all of the models have suggested that there is less expected death than the original model. This kind of just, for those of you that like numbers as opposed to graphs, this basically looks at the projected August 4th cumulative death from the COVID-19 model. And so you can kind of look at those, and again, these are on agmanager.info if you want to take a look. But in some respects, from the last model, the projected deaths in New York increased by 7. U.S., they decreased by about 8,500. Saw a little bit of an increase in Illinois. A little bit of increase in California, but it's still quite a bit less from the original models. A decrease in Florida, Kansas, and Texas. And this slide here basically gives that percentage change from the original model to the most recent model. In terms of the cumulative death, it has dropped by 62% from California, 80% in Florida, 4% in Illinois, 73% in Kansas. It has increased 40% in New York, dropped 77% in Texas, and the United States as a whole, it's dropped 27%. So concluding thoughts, again, this model has often been quoted in national, state, local, governmental decisions that basically caused a shutdown of the economy. And this is certainly having large economic effects for the U.S. in general and the agricultural economy specifically. One of the things that, from a modeler perspective, the change in data definition certainly has had effect on the U.S. and New York projections. And when you define the way that data is counted partway through the process and lump that all together, it makes modeling extremely difficult. And so in some respects, I do have sympathy for the modelers at IHME. There have been fairly large revisions to the cumulative death totals and the peak of daily deaths, both upwards and downwards with regards to the death totals. And then essentially the peak most of the time has moved to a closer date, such that many of the states, the expectation was that the peak would be in May, but for the 7 states in the U.S. that we looked at, the peak has actually already occurred. One of the questions, and we'll leave you to ponder this as you think about this, and are the revisions due to society flattening the curve, due to a change in behavior, or is it due to inaccurate models? And certainly this is a question that really becomes important, especially if there was some thought of a second wave and whether or not modeling would occur on a second wave. It's really a question that policymakers and society in general is going to have to wrestle with regards to that, in terms of are the reductions in cumulative death due to society behavior or inaccurate models. And so with that, hopefully this has been informative. We hope to do this next week. And so have a good rest of the day.